Still works? Something ugly? Two something uglies? Okay, good. All right. Excellent. I avoided tripping this time. Okay, so in my mind, this is day one of calculus. Everything else we have done before has been practice. It's been the backstory. It's the opening act at a concert where all you really care about is the big performer. Today, the big performer takes the stage. Coldplay is coming. Okay, maybe Coldplay is the wrong analogy. I don't know. But I want to tell you a story about my friend, Sir Isaac Newton. And here's what Newton's challenge was. And no, he's not actually my friend. He's dead. Okay, get this in your notes, please. Okay. Sir Isaac Newton was studying functions. He was very interested in this idea of tangent lines and secant lines. Now, I'm curious, tangent lines and secant lines, you have studied them before. Does anybody remember anything about a tangent line or a secant line? What's the difference between these two? Jose, what do you remember?
One goes to the origin, one doesn't.
One goes to the origin, one doesn't. Not true. Not true, but thank you for getting in there. Tangent lines and secant lines. What's out there? What's in the memory banks? Go back to pre-calculus. Maybe you want to go back to geometry. In geometry, you guys talked about tangent lines and secant lines. I know, I met many of you back then. 7th period, Mr. Dawson. It was a thing. I know, I spent a lot of time with you guys. Tangent lines and secant lines. What do we remember?
Tangent. Oh, isn't the tangent line the one that goes like to a certain point rather than just test the graph?
Okay, I want to leave the graph and just put a circle somewhere over here. Tangent line, secant line. What's the difference? I want to get some hands on this. Tangent line, secant line. Eric, what's the difference?
Tangent line is perpendicular.
Tangent line what?
It's perpendicular to the point.
It's not perpendicular. It's not an issue of perpendicular. Look at the diagram. In geometry, I would call this a tangent line. I would call this a secant line. What's different, Carlos?
The tangent line doesn't go inside of the circle.
Okay, true. The tangent line does not go inside of the circle. That's true. The tangent line has 1 point. The secant line has 2 points. I like it. I don't love it. Because when a line, by definition, has an infinite number of points. But there's something about this 1 point and 2 point thing. I just want to tighten up what you said. Roberto.
Tangent line intersects one time.
Oh, that's so good. Tangent line touches how many times?
Once.
Once. Secant line?
Twice.
Touches twice. This is the big idea between tangent lines and secant lines. So when I say a tangent line, I need you to know, oh, touching once without passing through. It has nothing to do with perpendicular and parallel and all the other things. Secant line touches twice. These are our definitions. Okay, so here's what Newton wanted to do. He had a graph, any graph, doesn't matter, and he would pick a point, say, here's my point over here. And what he wanted to do, what he could do, and you guys could do this too, is draw in a line that touches the curve in 1 point. What are we going to call that line? What kind of line? Tangent. This is a tangent line. Okay? This is a tangent line. We're going to get like big picture and then we're going to get specific. What he wanted to do, what he wanted to find, is what I'm going to call tan. Tan for slope of tangent line. This is what he wanted to find, the slope of the tangent line. Now you guys have been finding slope for a very long time. 8th grade, Algebra 1, geometry. And you guys have formulas, right? What are some formulas that we remember for slope? I'll take anything from anybody. I heard y2 minus y1 over x2 minus x1. That might be familiar. Other ways that we find slope?
Rise over run.
Rise over run is another way that we find slope. Jose, you're frozen for a little bit. Any other ones? Y equals mx plus b is like the equation of a line. Okay? Depending on the way you want to write it, you also did like average rate of change, and you do like f of b minus f of a over b minus a. These are familiar? We've seen this before. Based was like, oh, and there was also like change in y over change in x. Sure, they all mean slope. But here's the thing. Every single time in your life when you have been asked to find slope, you need 2 points. 2 points. All these definitions, 2 points, 2 points, 2 points, 2 points. Newton wanted to find the slope of a tangent line. How many points on the function? 1. Do we see what the problem is here? You need 2 points, you only have 1 point. The point that we're interested in, okay, I'm going to call this A comma f of A. A could be any number. We're going to call this the point of tangency. Point of tangency. And here's what his idea was. I want to find the slope of the tangent line, but I need a second point in order to do this. And so what he said is, what if I pick a point over here, and I connect the 2 points with a line? What kind of a line? What kind of a line, everybody? I want to get the slope of the red line. But to do that, I need 2 points, I only have 1 point. So what he says is, let me make another point, and I'm going to secant line. And I'm going to label this point on the curve as x comma f of x. I hope everybody's mostly okay. You actually did this last year with Mr. Link.
Yes.
Okay, I'm just doing it a little bit better with colors. Okay. Now, here's the thing. Last class, they were like, wait, that's stupid. That's stupid. You want to find the slope of the tangent line. You pick this other point, and you're going to find the slope here. Is the slope of the green the same as the slope of the red?
No.
Are they even close?
No.
It makes no sense to say, find the slope of the secant line and say it's also the same as the slope of the tangent line. But here's what Newton did. He said, you know what? If I could pick this point, how can I make my estimate better? What if I move the point closer? And now I connect those 2 points. I've got another secant line, right? And the slope of this secant line might be closer to the slope of the tangent line. Well, if that's better, anybody get better? I want to get it to be the same as the tangent line. How can I make my approximation better? What if I pick it like over here, I hear some folks saying? Could I make a secant line now? Right, there's another secant line. Well, that's good, but this point's over here. And this guy's all the way over here. What if I get closer? Could we get closer? How close?
Super close.
Super close. We have notation for super close. Get super close, but don't get there. 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 You want to get that was really creepy. Sorry, friends back home. If what you do is you say, let me do f of x minus f of a over x minus a, this is slope. Right? This is slope between point of tangency and whatever this other point is. This is not tangent slope. This is slope of secant. What I want to do is get to slope of tangent line. To do that, I need these 2 points, the point of tangency and this other point. How close do they have to get?
Super close.
Super close. Our notation for this? Limit. I want to find the limit as x approaches a. F of x minus f of a over x minus a is slope of secant line. By taking the limit as x approaches a, those 2 points get closer, 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 and what starts to happen is that your secant line is almost identical to the tangent line. What we're finding here is tan at x equals a. The vertical bar just means equals, or at, sorry. This is our new handy-dandy formula. We're going to do some practice problems involving finding the slope of tangent line. This is how we're going to find the slope of tangent line. Questions so far? Is this somewhat familiar from pre-calculus days? Pre-calc, we've seen this before. Okay. All right, so with that in mind, if you guys could do over to page 35. I really wish I had started this way last period. I think I had to hit rock bottom before I got smart. What you've got in front of you is a graph. The function, I can't see it. Juan, what's the name of the function? It's what, negative x squared plus 6x minus 1?
Yes.
Okay, it's a parabola. And here's what I want you to do. With an index card or a ruler if you got them, but there's index cards in the middle of the table. I want to find the slope of the tangent line at x equals 1. So first of all, get me a really good looking tangent line at x equals 1. X equals 1 is the point of tangency. Excellent. Use your index card, it'll work. Right, I want a tangent line. Alright. So if I had a big enough ruler, I'd be drawing my tangent line right over there. Here's my point of tangency. The coordinates, I'm just going to label them as 1 comma f of 1. I think you can probably see from the graph that the coordinates are like 1 comma 3. Is it 1 comma 3? Okay. 1 comma 4? 1 comma 4, my bad. Okay. The blue line that I just drew, what kind of line? I want to get the vocabulary right here.
Tangent.
Tangent line. I want to find the slope of the tangent. Specifically, I want tan at x equals 1. Now here's the thing. I bet all 17 of you can tell me something about the slope of this tangent line. There's at least one thing you can tell me with certainty about this tangent line. It has positive slope. Is everybody okay with this?
Yeah.
Positive what number? You don't know. But we know that the slope of the tangent line must be positive. I can see that the line is increasing. What you have to do, and I'm just going to draw this so that you see it. We pick another point. I'm going to call it x comma f of x. I connect the point of tangency to this guy over here. What kind of line again? This is a secant line. I really care about the vocab. Finding the slope of the secant is easy. Your setup is f of x minus f of 1 over x minus 1. The mistake I want you to avoid is stopping here and saying, oh, this is slope of tangent line. It's not slope of tangent line, it's slope of secant because I have two different points. How do I move from slope of secant to a tangent line? I need to get that. Carlos was doing it, he's like, I think, right, we want this point to get closer to the first one. So you need to get the right limit. It's the limit as what happens? It's the limit as x approaches 1. If I'm grading like free response part of a quiz, even just getting there is probably going to get you the first point. Now we actually have to go and find that limit. Well, to find the limit, I need to know what f of x is. F of x, that's the name of the function. Is it negative x squared plus 6x minus 1? It's at the top of the paper. Negative x squared plus 6x minus 1?
Yes.
Okay, that's f of x minus f of 1. I need the y value at x equals 1. What's that y value?
4.
4. And I'm going to divide by x minus 1. If you want to clean it up a little bit, limit as x approaches 1. Negative x squared plus 6x, negative 1 minus 4 is negative 5 over x minus 1. All my limit masters, you know exactly what we're going to do. What are we going to do? Oh, you want to factor already. Did you already like plug in and try? I mean, with limits, the first thing I normally do is I try to plug in. If you plug in, well, you're going to get -1 plus 6 minus 5, 0, 0. That doesn't work. So you're right, we want to factor. You guys all have the capacity to factor. Here's my one recommendation. Because of this negative in front, I'd factor that out. So now you've got x squared minus 6x plus 5. It's so much easier to factor when that leading coefficient's a positive. Okay, take a minute, factor it. Last class I went too fast, this is where I lost them. I bet some of you already know how it's going to factor. Or there's something you're expecting is going to happen. Doesn't one of them have to be x minus 1 because we're hoping for some canceling? Okay, so if x minus 1 is one of them, what's the other one? If you're not sure, do the box. It should be x minus 5. The x minus 1's canceled. Okay, limit as x approaches 1 of -1 times x minus 5. Now I'm going to try plugging in again, and we get -1 times 1 minus 5, and if all goes well, positive 4. You guys are going to get some really good practice time in just a second. The significance of the positive 4. This is telling me tan at x equals 1. The slope of the tangent line at x equals 1 is positive 4. Does that match? Does that match what we saw from the graph? Right? Slope is positive. It has to be positive. Ivan was never going to guess 4, but we can use our limit idea, and this is really like where Newton did his thing, was using this limit as x approaches 1, f of x minus f of 1 over x minus 1, and getting 4. All right, so here's what I want you guys to do. If you could flip to the next page, I think you borrow this just for a second. You guys are going to do a little bit of an exploration. You're going to look for some patterns. There we go. Thanks, sir. Oh, I didn't want to erase that. My bad. All right, here we go. All right, the one we just did was x equals 1. The first column, you're going to tell me what are the coordinates for the point of tangency. I need an x and a y. Is it 1 comma 4?
Yes.
Second column, what's the behavior of the function at this point? What's the function doing? Increasing. Next column asks for the slope. What's the slope that we just found? 4. Last is the equation of the tangent line. Now, somebody earlier said, hey, there's something about m and b, y equals mx plus b. Yep. There's also another form that I like, mx minus x1 plus y1. The top one is called Slope-Intercept Form. The bottom one is called point slope. They are equal. They're going to give you the same line. It does not matter to me. I like point slope better because it's going to be so easy to write the equation. Y equals m. What was the slope? 4. X minus x1 is 1 plus y1 should be 4. So here's how we're going to divide and conquer. I've got 1, 2, 3, 4, 5, 6 groups. Okay. In part C, this is where you're going to do the work. Pedro's group, you guys are going to do the same process for x equals -1 and x equals 4. Okay, Carlos's group, x equals 0 and x equals 5 is what you guys are responsible for. Juan, x equals 2 and x equals 6. Kaylin's group, x equals 3 and x equals 0. Eric's group, x equals -1 and x equals 3. And Beto's group, x equals 4, and x equals 5. You've got 10 minutes. I want you to go through the same process again. Find the slope of the tangent line at your 2 points. We're going to pull everything together and we'll talk in a bit. So whatever 2 points I just gave you guys, you're basically going to repeat that process. What's the slope of the tangent line, build the equation, do all that. Be really careful with that first setup. If you get that wrong, everything falls apart. Calculus is 5 days a week. There are some other classes that might be true. So it's 6. I go 7. Right? I'll give you 8. So what's the point?
We're doing f of x minus f of 1 over x. Yeah. That's the equation.
So this is how we found the slope of the tangent.
That's to find m. I mean, after m times with.
So you want the slope of the tangent line at a different point over here. So what's that first setup?
Why? Okay, they would have told me how I get ready. But how do you say it? I'm good. Okay.
Okay, are there any of the friends in the room that are maybe a little concerned about how to start? Okay, thank you for the honesty. Okay, so let's say the point of tangency I'm working on over here is x equals -1. If you know what to do, just go. Just go. The key is this. You have your point of tangency. You want to find the slope of the tangent line. But right now, all I know is this point, -1, and whatever the y value there is going to be equal to. To get to the slope of the tangent line, we're going to pick another point. And I'm going to just exaggerate it that it's far away, and the coordinates are x comma f of x. Here's your secant line. And if all you do is f of x minus f of -1 over x minus -1, what you're finding when you do this is the slope of the secant. My goal, though, is to find slope of the tangent line at -1. So that's why I also have to take the limit as this x value gets closer to -1. So your setup for the guys in the back, limit as x approaches -1, because that's your point of tangency, f of x minus f of -1 over x minus -1. And then you finish from there. At 3. Good. So your setup, perfect. Limit as x approaches 3. F of x minus f of 3 over x minus 3. And then you just, it's all your limit business. You're going to do some factoring, you're going to do some canceling, go ahead. Keep writing that limit.
Is it adds up to 9 or is it adds up to 0?
So you want to be careful. If you're factoring out the negative, you're factoring it out of all three terms. So it's x squared minus 6x plus 9. They need to multiply to 9 and add up to negative 6. Can I see? I just want to see your sign. Which point are you in? X equals 2. So that means that the coordinates here are 2, comma, f of 2. So your setup is if I read it mess them up. I know, but I went for the cap first. What you're looking for is slope of tangent line of x minus 2. So it's f of x minus f of 2 over x minus 2. So all of those need to match. All right. Good. Keep going. Yep. Keep going. Wait, I thought I'm confused. Here you've got negative 6, but then you decided to make a positive 6. Okay, so you know from the graph that this should be a positive slope, but somehow you're getting a negative answer here, so something's gone wrong. And I think what happened is when you factored out the negative 1, you've got to factor negative 1 out of all three of these terms. So it's x squared minus 6x plus 8. Okay, how are we doing here? Let's see the setup. Limit as x approach 0, f of x. Yeah, on this one, we're trying to get f of x minus f of 1. Here it's f of x minus f of 0. X minus 2, right? Right. Okay, keep going. Okay, friends over here. Excellent. No L, no R. So limit is so you get 0. Does it make sense? Yes. Good. Go. Get about 2 minutes.
I don't know. Oh, yeah, we got that.
Don't leave me. Stay. It's a good class. No. Oh, God. No, son. You're going to come here at lunch and sing at me? Please, God, go. Get enough drama.
Writing them down.
Oh, yeah.
Beto, you okay back there? Sounded like Ivan was tickling you or something. I'm not judging.
Come on, money making. All of the questions are here.
Limit is x squared.
Yeah, it's up to me. Minus 4? Or is it minus 5?
That's good. You're doing
No.
So you're starting at the right hand side?
we've already done it, and we have
Figured out, oh, the numbers
that's
are
what I'm saying, because they have to go.
then you would like make the mama diamond.
Where did you come from? Did y'all make the formula for something? So I write it down. It's for 4 on the
How do you call it?
for x equals 0.
All right, friends, I'm going to pull everybody back together. So if you can stop where you are. Okay, now each group got 2 points. It is possible that you get through both points. It's possible you didn't get through both points. That's okay. Shut up! Carlos. He's always like 30, there's like a 30-second delay between me and you. So I love the fact that you're like still going here. What I need you guys to do is capture all the information that we're going to get in your table, because then we're going to look for some patterns. So who had x equals -1? You get the guys in the back had -1. Who else had -1? Abraham, what did you guys get for your point of tangency? What are the coordinates? Okay, -1, -8. What was the graph doing at that point? Increasing. What was the slope? You guys got, what did you get for the slope? -6, I disagree. What did you guys get for the slope? Oh, that's a bummer. Neither group finished off the slope. The slope should be +8. I'm not sure why you didn't get +8, but now let's write the equation with the tangent line. It should be y equals 8, x minus -1, so x plus 1 minus 8. Okay, who had x equals 0? Okay, group up front. What's the point of tangency? 0, -1, I agree. Behavior of the function? Increasing the slope. Love it. Equation of your tangent line. Y equals 6 times x minus 0 minus 1, or y equals 6x minus 1. Either way to write it is fine by me. Who had x equals 2? Somebody had x equals 2. Somebody's. Men up front, what'd you get? Point of tangency.
2,7.
2,7. Behavior of the function?
Increasing.
Increasing. Slope?
6.
6?
Yeah.
I don't agree with 6. It should be 2. Okay. Y equals 2x minus 2 plus 7. If for some reason, if your group isn't coming up with the slope right now, don't worry. There's plenty of practice that is coming. Okay, we're going to get better. We're going to get better. X equals 3. Who had x equals 3? That was you guys. Okay, up front. 3, 8. What's the behavior of the function at this point?
Constant.
It's constant. It's that highest point on the graph, which for a parabola we call maximum is one way that you could refer to it, but for a parabola there's a special word. Begins with a V. Ends in vertex. The vertex, good. Hey, I'm tough. You guys need some help sometime. The slope at that vertex was 0, and hopefully not a surprise. Y equals 0, x minus 3 plus 8. That's too sloppy to live. X equals 4. Anybody get to x equals 4?
I got x equals 5.
You get x equals 5. Okay. At 4, the slope at the point is 4, 7. The graph is decreasing. The slope is -2. Y equals -2, x minus 4 plus 7. Carlos, you said you had 5?
It's 5, 4.
5, 4. Behavior of the graph?
Decreasing.
Decreasing. Slope?
-4.
-4. Equation of the tangent line?
Y equals -4, x minus 4. 5 on it.
X minus 5. And then it should be plus 4. Did anybody get to x equals 6? Okay. I'll give you a little nudge. 6, -1. Behavior of the graph at that point? Decreasing. Anybody want to take an educated guess for the slope of the tangent line? -6. Equation of the tangent line, -6, x minus 6 minus 1. That educated guess that almost everybody was able to instantly make is part of what I'm going after here. I want you to take a minute with whoever you're sitting next to. Once you've got all of this captured, I want you to write out a couple of things that you're noticing, a couple of patterns that you're noticing. Look at that whole collection of data. What are the things that you're seeing? Talk to the folks around you. Look at the table. What are you noticing? Okay, raise your hand if you've got at least 2 things that you've noticed. One person out of 17 has noticed 2 things in this table. 2 people, 3 people. How many of you have noticed at least 1 thing in this table? Ivan, give me 1 thing that you've noticed.
For the slope of the tangent, it comes from by 2.
The slope of the tangent line, what was that last part?
It goes by 2.
It goes by 2. Can you give me a mathy word there? Anybody else seeing that? The slope's decreasing by 2. Completely agree. If you did not get that written down, please write that down now. Okay, other things that we've noticed. Other people have noticed things. Go for it.
Either the when it's increasing or decreasing, that will determine it.
You said if the graph is increasing or decreasing, that'll determine, what was the next piece?
The slope of the tangent line is positive or negative.
Okay, so you're saying you can determine increasing or decreasing by looking at the slope of the tangent line, whether it's positive or negative? We're okay with that?
Yes.
Anything else that we're noticing? I'll take anything from anybody. Anything else that we're noticing? There's more. I won't tell you the more. I'm not a giver that way. I've heard that the slopes are decreasing by 2. There seems to be a connection between this increasing, decreasing behavior and the sign of the tangent line, the sign of the slope. Anything else? What do you mean they're almost the same?
The Y's are almost, they just repeat over and over.
The Y values are repeating. There's a reason that the Y values are repeating. It has to do with the parabola. There's a special word with the parabola. There's an axis of symmetry. Where's the axis of symmetry for this parabola? Passes right through the vertex at x equals 3. And as you move away from that axis of symmetry, you always have like balance. They're at the same heights. These are some of the things. This is all good. So now here's the thing. Some of you, in fact, you guys were all, was the behavior column really easy to do?
Yes.
Right, increasing or decreasing, you had a graph in front of you. So now it's time for a push. You know I'm a pusher, so I'm at the top of page 37 here. No graphs. I am going to take the graph away, and I still want you to be able to tell me how the function is behaving. Okay. Yes, Jose's excited. It's a piecewise function. I love me some piecewise functions. Okay, so you've got a piecewise function. First one says determine the value of tan at x equals 2. Using this information to describe the behavior at x equals 2. The other one, slope of the tangent line at x equals -2. I can never remember with this class. Are you guys, you like the easy problems or the hard problems?
Easy problem.
The easy problems.
Easy one.
Excellent, so let's go for the hard one. All right, so we're going to start on part, we'll start with A. You guys asked for easy, I'll give you easy. Okay, I want to find slope of the tangent line at x equals 2. Just get it set up. Find the slope of the tangent line at x equals 2. You have no graph. You don't need a graph anymore. You got some skills. Maybe not Kevin, but Slope of the tangent line at x equals 2. Okay, Jose is on the board. Jose has earned the first point. Beto's doing a whole lot of stuff, hasn't earned himself a point yet. Naum is on the board, he's earned a point. Eric is kind of getting close to a point. Carlos, depending on what you write next, you might get a point. Juan is on the board, he's earned himself the first point on a quiz. Kaylin's got 2. Alright, just real for anybody who isn't doing so well here. To find the slope of the tangent line at x equals 2, it is going to be f of x minus f of 2 over x minus 2. Take the limit as x approaches 2. That is our definition of the derivative. This is how we're going to do this. Sorry, I just said definition of the derivative. I didn't mean to say that. All of this here means slope of the tangent line. And Abraham, if that happens on the next quiz or the next test, you've locked in the first point. Here's the good news. All the new stuff is done. It's all the old stuff now. How am I going to find the limit as x approaches 2 of f of x minus f of 2 over x minus 2? What's f of x? X cubed, square root of x plus 2 plus 5?
Square root of x plus 2 plus 5.
You gotta choose. You gotta know which one to pick. Which one?
Second one.
Second one. Why the second one?
Because we can see that x is -2 is greater than 0.
Well, I want to be careful. We're finding the slope of the tangent line at 2.
Yeah.
The x values are supposed to get close to 2, which means we're going to be greater than or equal to 0. Eric, you with me? You look like you're having really deep thoughts back there. Square root of x plus 2 plus 5 is f of x. Minus, now I need f of 2.
7.
F of 2, you're going to plug in 2 here. 2 plus 2 is 4, square root of 4 is 2, 2 plus 5 is 7 over x minus 2. Alright, limit as x approaches 2, square root of x plus 2, plus 5 minus 7, let's make life a little bit easier.
3.
How about 2, Carlos? Over x minus 2. Great. Carlos is frozen for a little bit. Need somebody else. What are we going to do? How are we going to evaluate this limit?
Get rid of those.
Definitely the square root is the key here. Did anybody actually try plugging in 2 first? If you try plugging in 2, you get square root of 4 minus 2 over 2 minus 2, which is 0 over 0. It's probably not even a surprise to us at this point that it's 0 over 0. So, Juan said, side conversations need to end. So Juan said, I want to get rid of the square root. I agree. How do we get rid of the square root? We need fancy 1. Specifically, I'm looking for it's the conjugate. Square root of x plus 2 minus 2 over x minus 2. What do we multiply by? It's the square root of x plus 2 plus 2. In the bottom, square root of x plus 2 plus 2. And that's just fancy 1, so not a surprise. It's ugly. It is way ugly. So be careful. I think a lot of you guys know the trick. You know what happens when you multiply by the conjugate. If you don't know the trick, I would go off on the side and do the box. Square root of x plus 2 minus 2. Square root of x plus 2 plus 2. First box. Square root of x plus 2 times square root of x plus 2 is x plus 2. The next box. Square root of x plus 2 times negative 2 is negative 2 times the square root of x plus 2. Bottom box. 2 Square roots of x plus 2, bottom box?
-4.
-4. And what happens? What always happens? This guy up here and this guy up here cancel out. And so it's just the first guy squared minus the second guy squared. X plus 2 minus 4. I think you guys have a better way to write that. Is it the same as x minus 2? Now, some of you sometimes, like when I see you work with the limits, you start multiplying out the denominator and things get ugly really quickly. And I always tell you, don't do it. Don't multiply out the denominator. Why am I not going to multiply out the denominator here? Because there's an x minus 2 in the denominator that cancels with the x minus 2 in the numerator. Okay. X minus 2 cancels out with the x minus 2. Take that limit as x approaches 2. We've got 1 over square root of x plus 2 plus 2. Give me just 1 second. 1 second. Evaluate at 2 means I'm going to try plugging in 1 over the square root of 2 plus 2, which I think is a fourth. Is everybody good with the fourth? Okay. 1/4 isn't the answer. Or at least it's not the final answer. What we know from all this work is that the slope of the tangent line at x equals 2 is a fourth. That's great. But they also are asking about the behavior of the function. What's the function doing? You can't see it. It's not on the paper. What's the thing that we know? Because the slope is positive, I don't even have a graph I can see. But I know that the slope of the tangent line is positive. So the graph is f of x has to be increasing. Now be careful. Don't make the big mistake. F of x is increasing doesn't get you the point.
Alright, A equals 2.
Right, the only thing you know is that f is increasing at x equals 2. What was your question?
You went from x plus 2 to x minus 2.
Right. X plus 2 minus 4. Okay, 2 nights homework. It's assignment 14. It's on page 64. It's just 5 problems that involve finding the slope of the tangent line. It's going to be really good limit practice for those of you that need that limit practice. It's on page 64. You already have the solutions emailed to you. This time of our life is coming to a close. The whole I tell you there's homework and then I send you the solutions. Tomorrow is the last time. On Monday, we get back to real homework mode, which is good for next Thursday's test. See you later.
See you next Thursday.
Yep.